Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today I am going to discuss uh, first year topic, chapter 1, measurements, and the topic is the precision and accuracy. This is frequently used the term precision and accuracy in the measurements made in physics. It is very much important that they must be distinguished clearly. The precision of a measurement is associated with the least count. So, precision is related to the least count of the instrument, whereas accuracy is associated with the magnitude of fractional error. So precision is related to the least count of the instrument, and accuracy is related to the fractional error, or we can say that a relative error in measurement. So precision does not mean accuracy, but both are highly demanded while making measurements in physics. Precision and accuracy can be understood as smaller the least count of the measuring instrument, better will be its precision, and similarly smaller the magnitude of fractional or relative error, better will be its accuracy. Precision is also indicated by the magnitude of uncertainty in a measurement. For understanding the concept of precision and accuracy more clearly, we need to understand how to indicate uncertainty in measurement. So, precision is related to the uncertainty in measurements. In 10th class practicals, you find some errors like you calculate the value of a solid cylinder, or you calculate the length or diameter of a cylinder by using vernier caliper. So just for calculation the measurements will be 8.12 into 10 raised for, suppose this is the any value, and you can write this by 0.01. So this is the least count of any instrument. Suppose this is the least count and this is the measured value and this is the least count. In any electronic devices, you can see in your mobile charger there will be some like voltage. It's mean the current 5 ampere plus minus 0.01. So what will be this value? This is the uncertain value, like the fluctuation in current will increase that much and also decrease that much, so no electronic devices fall down. So for accuracy, we can say that the room temperature is 25 and you can just go outside and measure the value, and the temperature will be 27 centigrade. So you cannot say that these two temperatures are accurate. When we say that both are equal, when they are equal, we can say that these both temperatures are accurate. Or you can measure the value with vernier caliper, and also the other student measure the value from the screw gauge. So both measurement when equal, so we can say that the answer will accurate. In other terms, one student should perform an experiment like he measured the time period for simple pendulum, and the time period will be suppose uh, 10 seconds. This is the time period for first student. The other student measure the time period and which is equal to 10.1 second. The third student measure the value and the time period will be. So these we cannot say that these three have accurate measurements, because the time period will change some values. So for that terms we here in measurements we can use the term uncertainty, and now we can find how we measure or the uncertainty in the final result. So I'm going to describe some rules for measuring uncertainty. So now I'm going to discuss the main topic, which is more important, the paper point of view or your eta point of view. So how you calculate uncertainty in final result. Final result means your end answer. So the first is rule for addition and for subtraction. First rule for addition and subtraction. We are going to find the result. Let x, we are going to find the result for x due to the addition or subtraction of y and z. We can write this. This is for addition, and we also for subtraction we can write this. So in general, for uncertainty we are going to find these questions. This is the general formula for uncertainty or measuring the uncertainty in the final result. We are solve an example where this is the example 1.3, and they said that if d1 plus delta d1 is equal to 24.0 plus minus 0.1 centimeter. So this is the actual value. This is the d1, and the change, or you can say that for the uncertainty represented by the delta. So the uncertainty in this measurement is 0.1 centimeter. Represent the internal diameter of a metal ring, and the other value is d2 plus minus delta d2 is equal to 30.0 plus minus, and the delta d2 represent the uncertainty, and the uncertainty in this an external diameter. Then find the thickness of the ring along the with uncertainty. So the thickness, we represent the thickness by small t. So here the thickness, the formula for the thickness is d2 minus d1 divided by 2. That is equal to, these are the actual values. This is d1 and this is d2. So put the values. So 30 minus 24, the answer will be 6. So 6 divided by 2, and the thickness is 3 centimeter. Now just we find the actual value like this, and this is equal to 3. Now we are going to find the thickness, the uncertainty in the thickness, which is denoted by delta t, and the answer for this is plus minus. We can use this formula. Delta x means this is the change or uncertainty in the final result. So delta t is equal to plus minus. So delta y means delta d1 plus minus, or sorry, for just plus, and the other is delta d2. So we are just add the uncertainty in the final result. So the end result will be plus minus 0.2, 0.1 and 0.1, they both are adding. So we can write in general the value for t is equal, so t for t plus minus delta t, and the answer for this thickness is 3 plus minus 0.2, and the answer is centimeter. So this we can find by addition or subtraction. We subtract the actual values and we add, it means we subtract the actual values and we add the least count. We add the least count at the final result. So how we find the uncertainty? By addition or subtraction. We just subtract, these are the actual values and these are the least count, by subtracting the actual values and by adding the uncertainty or least count at the final result. So this is the answer for calculating the uncertainty by using addition or subtraction. So our next rule is product and quotient. Our second rule is for product and quotient rule. So if we have x is equal to yz, or we use this as a product, and or we have x is equal to yz, and this is for quotient rule and this is for product rule. If we have both of these in any measurements or any given formula, so then percentage uncertainty in x, percentage uncertainty in x will be equal to the sum of percentage uncertainty to the sum of percentage uncertainties of the given values. It's mean we are going to find percentage uncertainty in, let's suppose we are measuring the percentage uncertainty in x. This is x. So this formula is both for product as well as for quotient rule. We are use this formula. So percentage uncertainty in x, this is equal to the percentage uncertainty in y plus percentage uncertainty in z. So for both rules, how we find the percentage uncertainty in x? We just add all the percentage uncertainties. For we also add, first we find the percentage uncertainty in y, then we find the percentage uncertainty in z. So and then add the percentage uncertainty. Like for here, first we find the percentage uncertainty in y and then find the percentage uncertainty in z. Both answers add, we get the percentage uncertainty in x. For this, I am going to solve a numerical if we have a voltage V is equal to 7.3 volt, and the percentage answer or the uncertainty, sorry, for uncertainty in this voltage is plus minus 0.1. This is also the least count in voltage. If the value of the current is 2.73 ampere and the uncertainty in I is plus minus 0.05 ampere. So the question is, find the value and percentage uncertainty in R. R is the resistance. So you remember the formula for Ohm's law, V is equal to IR. So from this we can find the value of R, which is equal to V over I. So this is the quotient formula. So we use the quotient law. For just the value of R, remember students, for just finding the value of R, not I am saying uncertainty, I am just saying for value of R, just divide the real or the actual value. These are the actual value. I am denoted the actual value by AV, and these are the least count. So you are getting my point, students? For just real value, I am dividing 7.3 volt divided by 2.73 ampere. So the answer of this is 2.7 ohm. This is for just the real value, just denoting like the value of V is 7.3, is the actual value of I is 2.73. So the actual value of R is 2.7. And now I am finding the uncertainty in R. So for this I am going to first find the percentage uncertainty in V and also find the percentage uncertainty in Y. Then from this I am adding the values of V and I just want my percentage uncertainty in R. I am just writing this percentage uncertainty of V. This is called percentage uncertainty of V. I am just writing the abbreviation like for finding the percentage uncertainty of V, least count divided by least count of what value? Least count of the V divided by actual value. This is my own formula. When we divide, like the least count of the voltage is equal to 0.1, and if I divided 0.1 by 7.3 and multiplied by 100 for the percentage, so I get the percentage uncertainty in V, and for this you can calculate. The answer is 1.37%. Now I am going to solve the percentage uncertainty in I. So for the percentage of I, just remember this formula, least count, this is equal to 0.05 divided by 2.73, and if I multiply this with 100, so I get the percentage uncertainty, which is almost equal to 2%, nearly equal to 2%, not completely equal. This is also 1.97. You can calculate this. So I can say that this is nearly equal to 2%. So now I am going to finding my final result, and I am going to describe the percentage uncertainty of R, which is equal to the percentage uncertainty of V plus the percentage uncertainty of I. I'm just adding these two values, 1.37% plus 2%. So I get the final result, which is equal to 2.37%. So this is the actual percentage in value of R. So I can write this in the form of like how I write the final result in R. So I can write like R is equal to 2.7 ohm with percentage uncertainty with 3.37%. It means this is the percentage uncertainty in A. But if I am going to write this in plus minus, so I can write this as R is equal to 2.7 ohm plus minus 3.37, like 3.37% of what value? 2.7. So if I can solve these answers, so I can get in plus minus. This is 3.3%. 3.3% of what value? The original value. So the answer will becomes R is equal to 2.7 plus minus 0.08. You can solve this and the answer will be 0.08. So from this method we can solve the uncertainty in final result. One more and most important rule, which is not the last one, but here there is most important rule, and which is equal to the power rule. No, the third one is the power rule. If in you remember, like the formula for kinetic energy is equal to half mv square, or the formula for volume is meter cube. So for that powers like cube and square, how we solve uncertainty, how we can solve uncertainty for that power. So now I am going to describe power of a quantity or power rule. Like I have a volume of a sphere, like you know that V is equal to 4 by 3 pi r cube. So this is the formula, and if we have a value and the question is find the volume of a sphere, if we have the value of R, which is equal to 2.25 plus minus 0.01 centimeter. So if they give us only the value of R, so how we can find the percentage uncertainty in this power formula? For this, we know that the value of we just for actual value we can write this V is equal to 4 by 3. You know that this is the actual value and this is the least count. 4 by 3 pi means 3.14 and r cube means 2.25 cube. So we just use the actual value for finding the actual value of V, and this actual value is equal to, you also calculate this, and this will becomes, and that is equal to 47.7 centimeter cube. Now I am finding this uncertainty in volume V. So for that I am going to first find percentage uncertainty in R. For finding the percentage uncertainty in V, for that I'm just solve first the percentage uncertainty in R. So what is the formula for finding the percentage uncertainty? Remember, least count divided by actual value, and for percentage multiply that value by 100. So the actual value of from this is 0.4%. From this the result is this. But now I am going to finding the percentage uncertainty in the final result of V. So in previous in power and quotient rule, we just use the percentage uncertainty of a variable. Like here we are use percentage uncertainty of R, but for quotient but for power rule, one thing will be remember that we just write the percentage uncertainty which is equal to 0.4%. But here, what is the power of R? That is, here the power of R is 3. So for power rule, we multiply the percentage uncertainty of given variable multiply by the power of that quantity. So from here, the percentage uncertainty in V is equal to 1.2%. So here we can say that V is equal to 47.7 with 1.2% of uncertainty. And if I am going to write this in the form of plus minus, so how we can write this 47.7? I can change this percent, means one we can write 1.2% like this, 1.2 divided by 100, and this is the value of 47.7. So the answer of this uncertainty is 47.7 plus minus 0.6 centimeter cube. So this is the power rule. You can also solve any question like you can solve any question, or in your exercise there are too much question which is solved by this method. You can also check that for finding the length of a pendulum, you can see that the time period of the pendulum is 2 pi L over G and under root. So for finding the length, so we multiplying or squaring both sides, t square G divided by 4 pi square, and that is equal to L. So for finding the uncertainty in L, we are using the power rule for finding the uncertainties in length. So here, from here we can solve this, but the value of G are given. You can solve, just add the value of G because the power of G is 1. So the uncertainty in G multiplied by 1 plus the uncertainty of T multiplied by 2. So from this method we can solve the power rule. There are some uncertainty measurements in many values, like for finding the average, you can add all the values and divide it by the actual value or amount of the value, you get the average or mean value. For deviation we also use these experiments. But the important thing is this, the uncertainty in the timing experiments, like in simple pendulum. In this experiment, we use the time period for 30 vibrations, for 20 vibrations. So for that, first we find t, and how we find t? T is equal to the total time of vibration divided by the total number of vibration. So in timing experiment, first we find the time for, let's suppose I am going to find the time period for 30 vibration. So I am going to solve this for one vibration. So for that one vibration, I divide the total time of vibration divided by number of vibration. Like for 30 vibration, the time given by the simple pendulum is, let's suppose, 54. This is the time taken by, that is 54.6 second. This is the time period for simple pendulum, or you can say that for 30 vibrations, for 30 vibration. So I'm going to solve this by finding the uncertainty. I'm just 54.6 divided by 30 and multiplying or adding plus minus 0.03. This is the uncertainty in the actual value. So for this method, we can find the uncertainty. I'm also explain this in detail in classroom as well as, so students make practice for these are the very important, and most of the question is in paper point of view, most of the question, or let's suppose the 4 marks question will include it in your paper, in final paper, in annual paper. So keep watching, and thanks to all the students.